First up then, we have Steph. So Steph Stedman, who, when she's not helping us to make our way efficiently around London by analysing vast quantities of TfL data, is volunteering for the AGI's events team. Steph's also a chartered geographer with over 10 years GIS experience, and in this session she'll tell us a little bit about how TfL automates the update of their asset inventory on a daily basis.
So yes, my presentation today, I'm going to be looking at how we use FME Server to update out-of-date data in our corporate GIS. So I'm kind of assuming that most people know who Transport for London are, but for any of you out there that don't, we're the government body responsible for transport in the capital. A lot of people know us for London Underground and the iconic red buses, but we actually look after a lot of other modes of transport as well. We've got trams in South London, and we also do things like licensing all the taxis and private hire vehicles. So these are just a few statistics about some of the assets that we've got out there, which are getting used by people every day. So personally, I work within TfL engineering, and I'm focused more on the London Underground side of things. So the way that we identify the location of all of our assets is by using linear referencing. So this is the idea that we give sections of our track a particular code that we call a LCS code. So this might range from one station to another station, for example. And then particular assets and features are described by measures along these sections of track. So we might say something like a signal is located 100 meters in on LCS code, blah, 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 blah. Or a particular material is in use from 250 meters to 2000 meters, again along a particular LCS code. So we use this to identify assets along the track, but something else that we also use it for is to identify where we've got restrictions on the network. So the kind of restrictions I'm talking about are, if you think about the underground part of our network, it's a very restricted environment. As you can see in the picture, the way the trains fit in the tunnel, there's really not a lot of movement, there's not a lot of space down there. So we record all the clearance values, so how much space is available on either side and on top of the train. And this also influences things like the maximum speed that a train can go along particular parts of the network. Obviously, if it's a very restricted part of the network, we're going to take the trains slower around corners and things like that. So all of this restrictions data is stored in a database, which we call the Restriction Management System Database, or RMSD, a lot easier to say. And this is a SQL database with an access front end, which I've got a nice blurry picture of there. But this database hasn't got any graphical sort of display in it. It's just going to have, again, those kind of measures saying from this measure to this measure, this is the kind of restriction that's in place there. So what this project was looking at doing is taking some of that data and putting it into our GIS system. So the database I was talking about earlier, the RMSD, that gets used by about sort of 10 to 40, kind of specialist track engineers, whereas our GIS system, that's got sort of thousands of users and a lot less technical knowledge is needed. We all love maps here. You can just go on and find the information that you want. So this project was looking at updating that data and making sure that it was always up to date, taking the latest data from the RMSD and putting it into the GIS for everyone to see, and to look at it alongside other data sets that we've got in the GIS that might be useful for the projects and things that they're planning. So where does FME come into this? Bang in the middle. So on the left side of this diagram, we've kind of got people updating the restrictions data. So they're either doing that through this front end, through this access front end. Potentially there's going to be some power users who are a bit more SQL savvy, who might be doing bulk uploads to their database. And then we've got a Workbench, which is running every night on our FME server, and that's spitting it out to our Oracle spatial databases. and into the web GIS that I was showing earlier. We also have other applications that use this restriction data. So again, FME will spit that out into those applications as well. Like a lot of you, we have different data environments. So we have a development, pre-production and production environment. So FME will do particular tests and write out to all of those environments so that we know that we've got consistent data across our system. So this is the original workbench that I was sort of working from, which someone before me had created to kind of look at that data and start bringing it into the GIS. And this is the rather complex beast that I turned it into. But it's all very good stuff, but yeah, it seems a little bit more complicated than how it was before. So I'm not going to go through this entire thing and tell you guys everything that it's doing, but a small little bit of an overview, reading in various tables from the SQL database, so things like the maximum speed data, the clearance data, and other data. So reading in all that attribute data and doing some manipulation to those attributes. We're then reading in the entire track geometry. So the track geometry will change from time to time. We're doing a lot of works all the time on improving things. So that gets read in and then gets combined with the attribute data, which will have those measures in it. And the key tool that I'm kind of using in this project is a transformer called the Snipper, which will then snip that geometry to those measures and create some geometry features, which I can then map into the GIS system for people to see. So what a lot of this database is actually doing is a lot of data validation, a lot of checking data, and then if there's any errors, what it's then doing is spitting those out in an email to the data owners so they can go back and check their data if there's some problems with it. So I'm going to go through a few of my favorite transformers that I found during this project. So the first one I'm going to talk about is the AttributeValueMapper, which pretty much does what it says on the tin. So in this example, I had various proposed works, which in the database were stored as these kind of codes, so G001, G002. And originally that's the data that was getting displayed in the GIS, but if you're not a track engineer, that probably doesn't mean anything to you. So it's just assigning an actual human readable value to that for people to use. And what we actually had was two different fields. So in some cases, there might be two proposed sets of work. So again, this was just looking at combining those proposals into one string. So you've just got one string of data that's telling you exactly what's happening with that site. So the next transformers I wanted to talk about was the Snipper, my new favorite. So what this section of the workbench was doing was something which is called dynamic segmentation, which is basically this idea of taking the measures, so that sort of 100 to 1000 meter measures that we've got, and then clipping the geometry from the all track model that we've got to then create a specific line or point that represents that particular restriction, so that it can then be shown on the map. So the first part was using the feature merger to combine the attribute data and the geometry data. And then yes, using the Snipper. So the Snipper is pretty interesting. You can do things, you can get an output as either points or lines. So if you want to just get points, you just put the same thing in the starting and ending location, and that will give you points for where features are. And what was really useful for us is that you can tell it to do the measures in 3D. So obviously our network goes underground and we need to bear that kind of 3D measurement in mind. So what this means is that the data in the GIS will always be aligned to the latest track layout, which was really important so that all our data lines up for everyone to see. And then the last little bit I wanted to talk about was lists and the emailer. So I'm sure a lot of you are probably in a similar boat to me. I feel like the beginning of my career was all about sort of making nice outputs and nice maps. And now I spend my life doing data validation and correcting people's awful data. So enter FME, where hopefully I can automate as much of this as possible. So the kind of errors and data that I was trying to validate in this particular workflow were things like measures that weren't valid. So people saying that things were at a measure of 1,000 meters when that particular length is only 900 meters long, or talking about LCS codes that simply don't exist, or maybe they've just got typing errors in it and things like that. So what I used for this was a lot of lists. Now, when I first started using FME, every time it spat out a list, I got scared and then ran away and tried to find a new transformer. But I'll tell all of you, if you don't use lists, go and start using them. They are really useful once you kind of get your head around them. So what I was using lists for in this case was to build a list of all of those errors, sort them out into a nice order, remove any duplicates, and then putting all of that together and then emailing that to the data owners so that they could update their data at the source, and then we could process the data from there. And again, if you haven't used the emailer, have a little go with it. It's really easy. And just like an email, you enter your subject, who you want to send it to, and then in the body, you can start doing things like bringing in the attributes that you've been using in your workflow into the body of the email, which is pretty cool. So once that workbench was all set up and kind of verified that it was doing everything I wanted it to do, I then uploaded it onto our FME server. And this is now running every night as a scheduled task on the server. So every day that data is getting updated for people to see the next morning when they log into the GIS. And we also get email notifications. So if this task doesn't run correctly one night, I'll get an email notification telling me what's happened so I can go in and check it and make sure everything's okay. So like I say, not very snazzy outputs anymore, but correct data. So this is kind of what our output data looks like in the GIS. Specifically, this is kind of all the green points showing particular speeds at that part of the network. But yeah, the benefits of all of this work are that we're giving people really up-to-date data. I think before the data was quite a few years out of date. It was just a snapshot of data from one particular time when someone did the update. And now we're getting daily updates, so people can use that for their decision making. The data is viewable by thousands of people rather than just a select few. We've also got new data sets in there, which we didn't have before. And in general, we've just kind of tried to make the data easier to use with clearer symbology, easier attributes that are just simpler for people to understand. And yes, a cleansed data set that people can kind of rely on and know that what's actually there is definitely true. And yeah, that's it. So if we've got any questions. Thanks, everyone.
Thank you, Steph. We have. There's a few in. So I've been making a note as we go along. So we had one, I think actually you answered it. We had a question about 3D. So is TfL's geometry in 3D, e.g. tunnels, track, or all? I mean, you sort of alluded to that with your Snipper comments. But do you want to expand on how much of your data is 3D rather than 2D?
I think it's always one of those cases, isn't it, where we do have 3D data in some places. We definitely need it in some places where we don't have it. But yeah, for things like the track alignment and stuff, we do, yeah.
Okay. Somebody mentioned, well, actually, I heard you mention as well, an access database front end. Can you expand on what the access database front end is doing a little bit? And is that a legacy portion of the environment, or is there a specific reason why it's being done with an access database?
Yeah, I definitely, if it's access, you know it's going to be a legacy kind of thing, wouldn't you? Yeah. So the whole restriction database used to actually just be an access database, and recently they've moved it to the back end is now stored within an SQL database, which is where I was kind of harvesting the data from.
Right.
They've kind of kept that access front end because that's what people are used to using. So if they are going out and making changes to the track, and they've got new restrictions they want to input, that's where the engineers will kind of input that data.
Mm-hmm.
I think in an ideal world, we'd eventually sort of maybe have all of this brought into one system where maybe people actually just input that data straight into a GIS front end. We kind of get rid of access and SQL. Phase 2.
Yeah, I guess we've always got this challenge of having to manage users' experience as well, and you know, if it's the biggest pinch point is often when users have had something for a while. If you give them something different, all of a sudden they stop using it because it's not what they were used to. So there's always a happy medium to strike with making sure that these systems are continued to be used. I had one from me. It's more of a comment, to be honest, because you talked about lists and encouraging people to go and have a look at lists. I just want to add to sort of second that, first of all, and also add to it that if you have got older workspaces that use lists, you should probably have a look at lists since FME 2019, because it is now possible to create lists to contain only the things that you want to include within them. In the past, when you generated a list, you ended up sometimes bundling together a lot of attributes that you didn't want to be included in there, and they're a lot more flexible now to generate much tighter lists, and it has a big performance implication. So if anyone's got older workspaces that use lists, they're worth revisiting if you need to get a bit of a performance bump. And I'm more than happy to expand on that separately. But thank you for picking up those. It's always nice to see my favorite transformer section in a session, because it's nice to get people familiar with new components. So thank you, Steph.
Thank you.